Now, on the previous page, we mentioned that it's not always possible to solve an exponential equation using the same base approach. Notice here, 4 and 15, I'm not going to be able to write both of those as the same base, so there's no way to use the approach from page 1. So instead, we're going to use an approach that involves using a logarithm. And this will look a little different, something we've not done before in any equation. It starts with isolating the exponential expression, so you want to get any base to a power on a side by itself. Now this says take the common logarithm of both sides, okay? You can also use natural logarithm, but in general, what we're really looking for, if anything, is if we can use one of our simplifications of ln of e or log of 10, those are convenient. Otherwise, it doesn't matter which logarithm you use. So here, I could use either one. It'll be the same. I'm going to do them both just to show you there isn't a difference in what the actual final answer is, just what it looks like. But the idea is we're going to take the logarithm. Now that means you've got 4 to the x equals 15. So in my first approach, I'm going to take log of 4 to the x and say that's equal to log of 15. So we introduced the logarithm there. We took the logarithm of each side. And that's because if these two things are equal, then the log of them should be equal. Now, in doing this, the reason we would do this is it allows us to get that x that was trapped in the exponent, and again, same base didn't help us, trapped in the exponent, because now we can use our power rule and bring that x out front. We can use our power rule to bring the exponent in front of the logarithm, and now that our exponent is actually just down here in front, we can then take that and consider log of 4 just like a coefficient, just a number. That's all log of 4 is. And divide both sides by log of 4. So get x equals log of 15 over log of 4. Now, this is what we kept calling before the exact answer. However, this is something you can also approximate, since you've just got logarithms of numbers. So with our calculator, our log button down here, I can just simply take log of 15 divided by log of 4 and get a decimal and take that to whatever number of places. So I'll approximate that to 1.953, we'll say. So again, this is what we call exact, and this is approximated. Now I'm going to go ahead and squeeze in here one example just to show you. This is how we use what we call the common logarithm, common log. But to use ln, to take this initial equation and take ln of 4 to the x equals ln of 15, there is no actual difference. We're just using log base e specifically. But that still has the power rule, where we can still bring that x out front, and we can still think of ln of 4 as it's just a value, just a number, and get ln of 15 over ln of 4. Now, while that may look different than this, both are exactly the same. My math lab would accept both of them as correct answers, and if you throw this into your calculator, you will get the exact same decimal as you did with the logarithms. So either one will work in this case. Like we set up here, we really only need to use a certain kind if we're going to be dealing with an e for a base or a 10 for a base, because then we can do some very convenient simplifying at that point. So speaking of which, our next one, notice it has a base of 10. Now, you can always check for same base, but we will not be able to write 120,000 as a base of 10, okay? So we will take this equation, and since we got a base of 10, we will use log. So log of 10 to the x equals log of 120,000, okay? But over here, log of 10 to the x, which is like log base 10 of 10 to the x, this whole thing simplifies down to simply x. And we want to make sure we know that, right? We want to do that simplification. That's one of our base properties. Now, over here, log of 120,000, right? That would be the exact form. However, since it's just log base 10, we can type that into our calculator, log of 120,000, and get a decimal of 5.079 if we round it to 3 places. So again, exact, approximate for our solution there. Third one here, a little more involved, because remember, we have to isolate the exponential expression. Well, right now, this e to a power has a lot of stuff going on around it. So we'll do things like move the 3 over. So 40 e to the 0.6x, but add the 3 over, turns that into a 240. We don't even want that 40 there. We got to get rid of that first. So we'll divide both sides by 40 and get that to be a 6. Now that we're here, and we have a base of e, right? There's no same base going on here, but we can use ln of the left and ln of the right. We take the natural logarithm of both sides, and right here, just like the one above, we've seen that ln of e is like log base e of e. All that goes away, and we are left with just 0.6x. And then on this side, ln of 6. And then, with this, there's actually one last step. We do want to get x by itself, so we even divide by the 0.6 to get ln of 6 over 0.6. And again, that's the exact value, and we have an ln button on our calculator where we can say ln of 6 divided by 0.6 and get the approximate of 2.986. All right, and one last example. So notice here, we've got an exponential expression on both sides, but that's okay because in a sense we can say each one's isolated. So that's all right. 5 and 4 are definitely not going to be written as the same base, so we will use our logarithm trick. It doesn't matter, log or ln. Generally, people go with ln because it's one letter less to write, but it's up to you. I'm going to go ln of the left side equals ln of the right side. Now, we can use our power rule. It's the whole reason we do this. We make these into logarithms so we can get those exponents out front. We just need to be careful about how we do it. X minus 2 is one thing out front. 2x plus 3 is one thing out front. And those parentheses are very important because we have to make sure we distribute this value, ln of 5, as just a number, to both of them. So that's x ln of 5 minus 2 ln of 5. And then same thing here, 2x times ln of 4 plus 3 ln of 4. Now, nothing's going to simplify here specifically, but we're going to work towards getting x solved for. Having an x here and an x here, the first thing we want to do, like any other equation would be, get the x's to one side, the non-x terms to the other. So I'm going to subtract this, the 2x ln of 4, to bring it over here. And I'm going to add the 2 ln of 5, the thing that doesn't involve x at all, over to, 2 ln of 5, over to there. Now, these are not like terms, so these do not combine. I just write them as x ln of 5 minus 2x ln of 4, right? Those two terms there, those are gone. Meanwhile, over here, those are gone. And again, those are not like terms, so I don't combine them. I just write them as separate logarithms. So I've just moved the terms with x to the left and the ones without x to the right. Now, the reason we do this, since we can't combine these, we see this x as what we'll just call a GCF, a thing in common that we can factor out of both those terms, leaving me ln of 5 there, minus 2 ln of 4 there. Notice if the x's are removed, then we're left with those two terms, x factored out. Okay, I'm not going to bother doing anything to the right side here. Ln of 5. But now, to get that x by itself, all we have to do is divide by this large expression that really technically just represents a number, right? That is just some random decimal we haven't approximated yet, but that's it. Divide both sides by that whole thing to cancel out, factor by factor, right? Not term by term, factor by factor, and we have x on the left, and this whole expression of 3 ln of 4 plus 2 ln of 5 over ln of 5 minus 2 ln of 4. And as far as an exact answer is concerned, that's it. There's no simplifying there to get that any simpler. Now, we could, if we wanted to, type that whole thing into our calculator. 3 ln of 4 plus 2 ln of 5 divided by, oops, there we go, divided by ln of 5 minus 2 ln of 4. And I'll show you what this looks like here. So type it all in one line, one step. You want to make sure that you have parentheses around your entire numerator, and then 3 times ln of 4 plus 2 ln of 5. And I wanted to point out you can put a multiplication sign there. If you don't, your calculator will understand it to be multiplication. It understands that. Divided by, and then your entire fraction needs to be in parentheses as well, ln of 5 minus 2 ln of 4. And so that will give us an approximate value of -6.343 if we round.